Okay, let's look at the Unit 3 review. Starting with this first question, it's asking us to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. What you can note is all three of these lines are all parallel. They have the indication, the little arrow, the red arrow in this case. And this is the measure of angle 1, here's the measure of angle 2, the measure of angle 3. Now since we know all these lines are parallel, we know that they form, with this transversal here, they form alternate interior, same side interior, alternate exteriors, same side exterior, corresponding, etc. So when we look here at this angle, which we're given, 133, and this angle here, 2, which we're given, we can tell if we're just kind of blocking out and not looking at this top line here. See the two lines? Those are alternate interior angles, so we know they're congruent. So the measure of angle 2 is 133 degrees. And then if we look at the angle 133 and angle 3, the measure of angle 3, we know it's supplementary to the 133 degree angle because they're same side interior supplementary. So this should be 47. And then the measure of angle 1, let's see, if we look at the angle just adjacent to the one that's 133, we can see that it is supplementary since it's a linear pair with that angle. These form a linear pair. So this must be supplementary, which we know is 47. And these are corresponding angles, 1 and the 47 degree one. These are corresponding, so we know this one is 47. There's a bunch of different ways you could have done that, so if you did it differently, that's fine, but we will always get those same degree measures. Number 2 here says given AB is parallel to DF. So I'll use red. This one is parallel to this one. Good. So which statement is true? The measure of angle D is 28 degrees, so let's see. Would this be 28 degrees? Well, no, because this angle is alternate interior to this one. Since this line DB forms a transversal cutting our parallel lines, D should actually be 43 degrees as well. So I'll just put a 43 here. No, this is not true. Angle A is 43 degrees. Well, if you look at this line as a transversal of our parallel lines, then you'd see that this angle is alternate interior with this angle, so it should be congruent, and since the angle that forms a linear pair with this one here, these must be supplementary, so actually this angle down here is not 152 but 28. Right, that would make 180. So angle A must be 28 degrees. So this is not true. Measure of angle ACD, that's this one right here. ACD, they're saying it's 71 degrees. Let's see. Well, if this is 71 degrees, then looking at this angle, it should be supplementary to 71. So instead of finding what's supplementary to 71, I will find, since ABC, this triangle here, every triangle has a sum of 180 degrees. So 28 plus 43 is 71. Then this will actually work out because this angle here is supplementary to 71. They need to all add up to 180. So let's see. 180 minus 71 would be 109. So since this would be 109, this angle here, ACD, must be 71 degrees. So this one is true. Let's just double check BCE. What's BCE? BCE. It says it's 109 degrees, but we know it's vertical of the 71 degree one, angle ACD, so that's also false. State the theorem or postulate that justifies each statement. It says if angle 1 is congruent to angle 4, then line P is parallel to line Q. Well, we know that we would use the converse of the corresponding angles postulate. I'll just say angles, corresponding angles. It says if P is parallel to Q, so if it's starting out with saying the lines are parallel, then the measure of angle 1 plus the measure of angle 5 equals 180. So you can see this would be the transversal in question. You don't even have to worry about this line down here. We're just looking at those two parallel lines in the transversal. We know that that would be true, that those two would add up to 180. Not by the converse, but just simply by same side exterior angles theorem. Okay, so that's the general idea here. This one we use the converse because we know we were trying to prove that the lines are parallel, in which case for number 4 is different. They start out with the hypothesis being that the lines are parallel, so we don't use the converse here. Let's look at a couple of these. Set up and solve an equation to find the value of the variables. Well, good, we have these indicators right here that these lines are parallel. So if they're parallel, it appears this one is 2x plus 12. The one that forms a linear pair with it is y. And this one here is 3x plus 23. So I see us setting up a system of equations. It doesn't tell us that here, but I think that's what we'll end up doing. So we can say since these are corresponding angles and the lines are parallel, we know they should be congruent. In other words, their measure should be equal. So we can set up this equation. And then if we look at this angle and this angle, we know that they should be supplementary. So y plus 2x plus 12 equals 180. Now, I think the easiest way to solve this would be to substitute. Since we know y is equal to 3x plus 3, we can rewrite the second equation, but instead of writing y, we'll write what y is equal to. Okay. Let's change this pencil to black. Okay, combine like terms, we get 5x plus 23 plus 12 is 35 equals 180. We subtract 35 from both sides, we get 5x equals 145. 5 goes into 100 20 times, and then 5 goes into 45 9 times, so we should have 29 is what x is equal to. So if x equals 29, we can plug it in for any of these. I'll plug it into this one. So 3 times, we said 29, plus 23 is this angle here. Highlight green. 3 times 29 plus 23. And we end up with, 60 plus 27, right? Yeah, 60 plus 27 plus 23, we get 110. So since these angles are corresponding, we know that they're equal. So y must be equal to 110. So that's a system of equations. You could do the same thing here with this problem, but you want to know you're doing one transversal at a time when you're looking at this. So start out with this one and say like, oh, this one are congruent. This one here and this one here are supplementary. Y would be congruent to this one over here. And then once you've kind of got an idea of that, you can come over here and look at this transversal that's cutting the parallel lines and say, oh, this angle and this angle are supplementary. Yeah, that's to the extent you actually need to do that. So let's go down to one of these problems. What's given? Angle 1 is congruent to angle 2. It says which lines or segments are parallel. Identify the converse that allows you to prove it. Good. So we really are only going to be able to find one set of lines that are parallel. So that set would be not these ones. Yeah, it would be these ones. Because if you look at this transversal, you can see it forms those angles that are congruent. We'll double check with the other pair of lines. So we get Q, what is this? PO? PQ. PQ is parallel to SR by, and we said these are alternate interior, right? Let's double check that. Yeah, those are alternate interior, so we would use the converse to prove the lines are parallel. Alternate interior. Let's look for these lines too, though, because it might be the case that both pairs, if you use this as the transversal. Oh no. Yeah, we can't say for sure because you have all this angle here and all this angle here, which at the moment we don't know are the same angles. So the point being here is, if you look at the angles, these ones, they don't go all the way to the parallel lines, or what we would hope are parallel lines. So those aren't alternate interior like we would hope they'd be.